Good evening, everybody. We have another meetup in front of us, and today is our guest, Christian Dywan from company SUSE. And why we asked him to share with us his knowledge? It was because we were talking with our colleagues in protest, and they suggested that he would be very good assets. And because we are listening to our colleagues, here we are. I will have a few questions during our session, but you can also ask on Slido or in a YouTube chat. This meetup is recorded, so you will find recorded session on the same link as this live stream. So now stop with me. I think that it's time from Cris. So Cris, could you please tell us something about you?
Sure. Thank you for the introduction. So yeah, my name is Cris, short for Christian Dywan. I am someone who really likes free software. So in addition to QA, I like to work on various products, and yeah, these sort of pieces of software tend to have bugs. I think it's common knowledge that every piece of software has plenty of them. There's no such thing as a release that doesn't have some kind of problems. And so yeah, here comes in openQA. So I work for SUSE, which is a Linux distribution. So there's the enterprise versions as well as openSUSE, of course, which is completely open and has a vibrant community. And so SUSE has a lot of test infrastructure. So that ranges from OBS, which is the open build system, to tests that come with the software that's being shipped in the distributions, as well as openQA tests to complete the cycle. And openQA tests, as you will learn, are a way to test the entire system under test with a particular piece of software, whether that is, say, your web browser, or whether that's some command line tools or the networking stack, without having to modify the actual system, without actually having to modify the software that you want to test. Let me see if I can share the slides now. This one. All right, you should be able to see the slides.
Yes, we are.
So the slides, so this is a bit of a teaser right now. The slides will be available online soon, unfortunately not quite yet. So there you see the URL that they will be available under. There we go. So a little overview of what I'm going to talk about. So I will try and give you an idea of what openQA is, how it works, how does it actually run tests, what does it actually mean, test, in the openQA context, because test is a very heavily overloaded term that can mean so many things. So it's actually quite useful to know what do you actually want to do. And I will give you a tour of the web UI. So when I say web UI, that means the web browser interface that is used to manage, to schedule, to review what's actually going on. And openQA also has a wonderful RESTful API. That is to say, you can post requests to make changes, to start tests, to edit test configurations and such via HTTP, and also very commonly by using command line tools. I'm also going to go into some detail later on. I am not going to be super specific on the technical details. I'll try and keep it to the actual semantics, so don't worry so much about those. Although if people are interested in the specifics, I'm of course happy to expand on the nitty-gritty bits as well. And yeah, I'm going to try and give you an overview of who uses openQA and what kind of tests you can actually run with it. There's the questions on Slido, which I believe Lucy has already mentioned. So feel free to ask questions. And I'll be happy to try and take some during the talk as well. Yeah, looking forward to your curiosity. So you're welcome to ask whatever you're interested in. All right, so the big question, what is openQA? QA is already in the name, and you're probably somewhat familiar if you're listening to this, what QA means. QA is quality assurance, of course. That is, you are using some kind of software and you kind of want to know that it works, that it does its thing. At least to a certain level of, this is what I know it should be doing, and I want to find that out. So what is special about openQA is perhaps that you schedule tests on what I'll call the system level. So that distinguishes it from a few other frameworks that you might be familiar with. So there is things like Selenium or Autopilot, for example, which are frameworks where you implement a test suite that tries to figure out what the software in question does, how it works, tries to introspect it, tries to figure out what is actually happening on the system. What's special about openQA is that it very much tries to cover the use cases of human interaction. So think of using your mouse to click something, to left click, right click, double click, using your keyboard to type something. If, for example, you're in the login screen, typing a password, opening a web browser via the menu of the system you're using, and then, for example, opening a tab on the web browser, typing a URL, opening a website. So that is very much the serialized version of what you would do to manually test something. And I think it may be worth mentioning, manual tests are actually a great base and also addition to automated tests. So many test cases I work with replicate the way you would look at a software and try to figure out what it's supposed to do and see if it works correctly by repeating certain steps. And of course, because it's scripted, you don't have to actually type it all the time, but openQA will do that for you. Should that not be enough, and of course, there's various use cases where you need direct input. So very commonly using SSH to open a shell on a system that is being tested. In some cases, also using a serial console to get access to the system. I'm going to get into some details on that in a bit on the actual backends that are being used. And you might be running scripts or running commands, installing things on a system that you need to be tested. Again, the way you do it is actually very much the way you would as a human. The actual software being tested is not going to be modified. You can run pretty much everything the way it is without, for example, installing a framework that works with the application you're trying to test. And of course, I mentioned the web interface before. So openQA also processes the results and tries to collect the test results. So if you imagine taking notes while testing something manually, that's the equivalent, which is to collect, of course, screenshots, log files, output from the console, debug information that you may want from the application that you're testing, where applications in this case can mean installing an operating system, it can mean the web browser. So there's various types of things you can be testing here, and I will get into a few details of that. So this diagram might help understand a bit better what I mean by this this process that is being done. So on the top left, you see this nice little stick figure that symbolizes the person using openQA. So very often that is looking at a website to interact with the web UI to see what the actual status of a test, for example, is that you're running. And that is alternatively using the REST API that is exposing pretty much the same things if you actually want to script the features that openQA has. So most of the things can be done through the API or through the web interface. And then the sort of magic actually happens behind, which is on the workers. which very typically run on separate machines. So you can, in the most basic use case, run the web UI and run a worker to run the tests. So in other words, the worker is the thing that actually executes your test job. So when I say job, that is to say, you've written a test case and you want to schedule it, and you wanted to run at a certain pace. You want to be able to rerun it if it fails. You want to rerun it as you're doing new releases of the software, as related dependencies might be changing. So in some sense, you could refer to this whole setup as a scheduler for tests, because it also includes the ability to figure out when and how to run tests, or what tests are dependent on. The OS autoinst in the diagram is actually the component of openQA that runs what you'd consider the actual tests, and, for instance, talks to a virtual machine in the most common case. In some cases also bare metal. So that depends exactly on what you want to test. You may actually be running openQA tests on different types of architectures as well. I'm going to expand on this in a moment. So QEMU is very commonly, or the most basic use case, which is you have an ISO that is an image of a system you want to run, that what you want to test. And you need to start it. So that could be something like OpenSUSE, or it could be SLI, which is SUSE Linux Enterprise. It could also be something completely different. It could be a Fedora image. It could be a Windows image. It could be Haiku. openQA pretty much does not mind what you're putting in there, because it's up to you to define what you're actually going to test there. So long as you make sure that you have the hardware capacity to run it. And of course, if you want to test certain more exotic types of hardware, this is where SVERT or IPMI come in. And then you might be using the serial console or SSH to interface with the system under test, because remember, you're basically running something like a user would. That is to say, the system is being installed. If you imagine installing the operating system in a virtual machine to try something out. And so you're going through the installer, you're going to configure hard drives, you're going to set up networking, you're going to create the user or multiple users, domain settings, depending on what specifically you're installing. And then once you have a working system, You're also, of course, going to install the application if it's not already part of the system. And at that point, you can interact with it. So you can type things on a console, you can click things with a mouse, you can type on the keyboard, and test the software in the way that that you need. So let's assume you have set up a few tests. So this is, for example, I picked the openSUSE Leap, one of the openSUSE Leap test groups as an example. This is actually showing the web UI. When you use the web UI to have a look at what you're actually building there, you would see the current builds that are finished. You can see when they were built. You can see that builds have passed. So for instance, you see a few passed ones, you see a few soft failed ones, and you see a few failed ones there in those nice and colorful bars. I'm going to explain in a moment what this actually means. You may not know the distinction, but I'll get into the details of what the actual status of a test is. So let's look at one of the test results. This is the summary as exposed by the web UI. There's an example of a test in the perhaps ideal case, perhaps less common case even, which is the tests work as they should. Everything is great. So you can see this is an openSUSE Leap 15.2 image. You can even see the build number in there. You can see the number of past tests. It has a few soft-failed ones as well. No failures in this case, which means if you look at the list of tests that have been run, you see these little green circles. That is color coding for everything passed, everything looks good, and these are fine. So all great, right? But let's see. I found another test, and that doesn't look as great, apparently. You might notice there's a bit more stuff in the description of the test. And it says, for example, the result failed, and it says it's finished 20 days ago. In this instance, it took 23 minutes. So this gives you a bit of an idea on the actual parameters of the test. You can see a description of where the test was run. Remember, all of those tests run virtual machines. So where it says assigned worker, and it says openQA worker 46, that is actually if you imagine being the person who maintains the servers and may have to debug if the backend is working. This would tell you where in your infrastructure they run. So at SUSE, for instance, we have separate production instances for OpenSUSE as well as for SLE for the enterprise distribution. And so they both have their separate infrastructure running various types of hardware. So in this case, it's plain x86 Intel, I believe. But yeah, so what actually happened there? Why is this red? So you can see if you're looking at the tests there, which are part of the installation tests, going from ISO size and bootloader and finished desktop and live installation. And you can see the first three ones say passed, and they're very green. And you can see these little screenshots there. And you might be wondering, what are these about? So keeping in mind that this is basically running a system like it would if you as a person were to install the system and configure things and do the setup in a virtual machine, or real hardware, of course, in some cases. This is the screenshots of the interaction happening on the system. So in the ideal case, you just have a way to verify what's going on, what's being done on the system. And so the screenshots, which we call needles, and openQA context, show you what the test run looks like. And this is going to become especially important as we're wondering why this test called live installation failed. What happened there? So as we're looking at those needles in a bit more detail, you'll notice there's a couple needles with a red outline as opposed to a green one, which means something with the with that step in the test is wrong. So here you can actually see that the test in this instance is at the desktop. So you might recognize the desktop icons there, which include the trash and the home folder. And there's also something called installation. So by the looks of it, the test is at a stage where the user, or that is to say the serialized user inputs, would be attempting to interact with the installation shortcut and try to open it from the icon. Unfortunately, that doesn't work. So this is where the needle candidate comes in. So I'm not sure if the text is readable, but on the screenshot it says candidate needles and tags. So this is because the run inspects what is expected to happen in the test case, and it goes by tags that match the test needle that is expected at the point in time that the interaction happens. So for instance, expecting a picture of the desktop during the installation and trying to see if the icon you see there is visible, except something seems to be wrong with the icon. So I'll give you a little spoiler. I investigated this test case a little bit, and it seems that there were some changes to the theme being used here. So this is becoming interesting. As you're wondering, how does the test even know where it's supposed to click, how it's supposed to open the symbol on the desktop? I'm missing the slide, unfortunately. Yeah, so going by the desktop icon, the test would have a specified area that it's looking for, and it would go by a certain match. So there's some algorithms to use the similarity index of the colors involved to see that this is actually the right icon. And in some cases, there might be a minor change, and the screenshot will still be considered to be the same as the expected one. And you can also see it's a 94% match in this case, but it's not enough to suggest that it's the same screenshot, which means the test fails because it may not actually be correct. So in this case, I think the test is actually correct, but the needle would have to be updated to make sure the expected result is available. So this is where the needle editor comes in. This is part of what test reviewers do in openQA. So if you found out that a needle doesn't work, maybe the needle is wrong, maybe something changed in the actual software. Like in this case, I think it is a difference in theming. So you very often have some changes in the branding and font sizes. The font face might change, the icons might change, little color changes. All of these potentially confuse the matching of the output. And so you need to make sure that the actual behavior of the system is what you're hoping to find. You can see in the little box there the JSON specification of the needle. So you don't necessarily have to edit it manually. This is more interesting if, for instance, you want to work with needles on the API level or edit them manually. But this is also, I think, useful to show what it actually means to define a needle. That is because it defines the area of the image that you're trying to inspect. So it has the position that you would click with a mouse and the size of the area as well. And I think I mentioned the tags briefly. These are to associate what you're expecting to see there. So if one of these tags, such as live-installation, are being found, you can use them in the test description to assert that a certain event has happened or a certain action has happened on the system. Now, Another type of failure, now that we've dealt with the failure and fixed the needle, we're looking at one that says soft failed. So you notice now the outline, the test overview is yellow, and it says soft failed finished, and it gives you similar overview of how long it took to run the tests, what machine it ran on, the name of the worker, and yeah, so we start looking at the tests. Again, we start looking at the ISO size, bootloader, finished desktop. So these are again fine. But clearly something hasn't worked quite like it should. Or has it? So the interesting thing about soft failed and the distinction of why this isn't simply a failure is there's a fair amount of cases where the test run on the whole ends up in a situation that you might have a known problem. You might have run the tests a few times before and found, okay, maybe there's a bug in the software. It's not my software. I'm using it, but I'm talking to the developers to investigate what's not working in that instance, and the developers will be discussing it with me on the bug report. So this, for example, has a Bugzilla ID attached, and it has a description of what the bug is. So if I were to look at the bug now, I would be following up on what's actually happening. There are comments on the issue. So what this means ultimately also, though, is if this is a bug that takes time to fix, that needs investigation, that needs discussion, we can still decide everything else is fine. It's no reason to consider the test failed. So instead, we record this for future analysis, but get on with other work, basically. And we can still run the test case, and we just have to keep in mind, once the bug in this case has been fixed, we can change the soft fails and see that it passes again.
I would like to interrupt you now, because this is very, very interesting area. I have a question. We see here in this soft failure Bugzilla number. And my question is, somebody put the Bugzilla number there manually?
Right. So there's a couple ways you can do this. There's a way to record a soft failed status in code as you're developing a test, and as if you already know that, for example, in certain scenarios, something is not going to work, and maybe you're trying to work around expected issues, but maybe you know it's not going to be possible, so you can mark it as soft failed. Or very commonly, if you're reviewing the test and you're finding something failed, and this is when usually you start investigating how can I fix it? Is it, is it an issue in the test? Is it like the case that was showing a change in the theming, something where you need to update the needles that are expected? Or maybe it is something that has to be followed up on by the developers of the particular software and cannot be fixed right now. So you add a comment with the bug that you filed, or maybe you found an existing one and added there, and then you mark it as a soft failed by putting the comment in there.
Thank you.
Did we have any other questions from Slido yet?
Not from Slido, but I have another question because another interesting thing is this needle concept. Mm-hmm. And my question is, you are gathering really a lot of information in your system, mm-hmm. Logs, screenshots, you have those information for needle. Is there any point also saving those screenshots for, for later consideration? Not just now, you are looking at this week results, but maybe you can somehow working with them in the future, because I think that you have really very much data there stored.
Yeah, so actually one thing that's really worth keeping in mind and day-to-day life of using openQA is you can easily end up with too much data. Or in other words, it really depends on the hard disk space that you have available on your systems. So if you run your tests on various types of hardware and you run tests on different versions of the same software, or maybe you're testing an app that you're making on different systems at the same time. So of course you will collect all of the screenshots, all of the test results, all of the logs. I do have another slide, I believe, will show this. So it is important to configure how long you will store the information for.
Okay, perfect. So let's continue, and I will ask there.
Mm-hmm. Right. Yeah. So this is as you manage the job groups. Like I was showing before, this would be the typical workflow as you're reviewing your test results. This is an example of what it looks like to edit one of the groups. So this being the Líbí 15.2 group. And for example, you need to define that your assets being the name of everything that comprises your test results. And for example, you have 10 gigabytes of storage. You should really so what we have in place as well, it's not necessarily part of openQA, but we use Grafana to monitor things like the health of the machine's disk space availability and other measures to make sure that things go smoothly in production. And you want to make sure you have enough space. and to also the log files, as you can see here, for example, keeping the logs for 20 days or 90 days for more critical log files. Yeah, and of course, you need to figure out somehow how these tests are scheduled. So what we're using these days is actually YAML to define the job templates, which is the name for the tests, to define. So I will read it out briefly. Not sure if you can see it correctly. You define the architectures that you're running your tests on. So for instance, there's x86, 64 there. You define the products, that is the actual system you're using to run your tests. So we have 15.2 GNOME live image. We have a GEOS image. We have a KDE live image. We have a rescue CD as well. So these are different images that are being used in the machines that are being tested, but also running the same test bases. And I should mention a couple of things. So like I said, I'm not going to be too specific on the technical details, but this is a very common workflow for people working with the tests, is to use the command line to interact with it. To, for example, read out the job details, to post a job or post an ISO to schedule a build. So you can see a simple example where, for example, you're posting a test that runs on SLE, which is SUSE Linux Enterprise. But of course, it can be whatever you're testing at the moment. This is just an example. It specifies the create HDD text mode test. It specifies the machine that's being tested, the version of the distribution that's being tested. So this is something that's really flexible. Some test developers have their own scripts to automate test runs or replicate tests on different setups. For example, a lot of people have their own instance to play around with, to mess with, and to test that their new tests are going to work before adding them to the production setup. And yeah, I also want to highlight a little bit, because it may seem like openQA is a lot about testing SUSE, which is of course true. And the examples I've been showing here are based on the tests we run at SUSE. But openQA is also used for various other use cases. And perhaps some people listening in are thinking, maybe I'm going to use openQA in the future. So for example, Fedora, another Linux distribution, uses openQA to test images with openQA. So Fedora also has its own infrastructure for this, its own machines running the tests. Of course, the tests adapted to their needs, and we have pretty good conversations going with people from Fedora to make sure that it works, to discuss use cases. They're different for Fedora. There's QUBES, which you might or might not have heard about. This is a virtual machine host. That is, the system is very much specialized in running a lot of applications in different VMs. So this is, I think, an excellent case because you're also able to test the whole operating system with openQA to make sure QUBES actually works. And of course, why not test how well Linux works on Windows by using openQA? So I could have probably picked an easier example for this as well, but I figured this is a pretty popular one these days. So if you weren't aware, it's possible to install SUSE on a Windows PC through the Windows subsystem for Linux. And this test actually finds out if that works. So the process going on behind these tests is installing Windows, running Windows, setting up the WSL integration, and trying to run a SUSE image inside of the running Windows system. Last but not least, openQA itself has tests for openQA because, of course, we want to know that openQA actually works. And besides, of course, using it a lot ourselves, we have a few test cases that check that you're able to set up and run openQA on a fresh system. And I believe that's the end of my slides.
But unfortunately, I have bad news for you because this is not probably the end of your presentation. I have a few questions.
Right.
You were talking about the thing that one of your users are guys from Fedora. I think that this is pretty interesting and it must be really interesting use case. So did they suggested something what was interesting for openQA from their point of view?
Yeah, so we have the occasional ticket being filed, or also pull requests being proposed from the Fedora side. For example, very recently, one case that came up was some differences in the networking setup and the openQA setup in Fedora. There were some changes in the infrastructure, and it turned out they needed more freedom in the host name assignment, or that is to say the assignment of IP addresses in their infrastructure, which for whatever reason isn't very flexible, probably because nobody really had a need to refine it further, to customize it further. So in this case, Fedora is helping us improve the setup and make it more dynamic and make it more flexible.
Mm-hmm. This is really interesting because obviously you are working with your users on improving openQA. Try to imagine that somebody from our viewers decides to try openQA. What are prerequisites? What should we do to try to use openQA?
So generally speaking, in terms of the setup, if you want to try it out and see how it works, you'd be pretty okay with having what's probably already your development machine and installing the web UI and the worker that is always the component that runs the tests for you. And you want to make sure that you have probably 8 gigabytes of RAM on the machine to run the virtual machine properly. And if, for example, you're running something on a Linux distribution, which I think right now is the most common use case for openQA, although, like I said, it's not specific to that. It works with other operating systems as well. But you want to make sure that you have an image that you can install to run your tests in. And if that's installed in, for example, QEMU works, you can then run the test cases to boot the system, see if you're able to log in as a user and do some basic things, and probably go from there, like running your application, which, depending on what it is, it might be something that you install, you open the window, or you need a web server. If it's a web-based application, so you want to make sure that the web server is available, and then use a browser, for example, to open your application and see if it works.
Okay, it sounds like a usual setup we are using for using other frameworks. So let's look at the manager's point of view. As you know, managers like reports and graphs and pie charts about passed, failed, soft failed tests, bugs, and so on. Are you using only the view we saw in openQA, or are you connected to another report system?
So since this is definitely a recurring topic, we are integrating the information you see there with a few other tools. So, for example, we're integrating these with Redmine, which is used for ticket management, to, for example, verify what the test coverage is on certain things. Also, as mentioned, Bugzilla instances to make sure that any failures are followed up on, to investigate why they're failing. We have a few sort of homegrown tools as well that are used internally to link the data and, for example, see what the curve is. We, of course, aim to reduce the amount of failures and see how quickly reviews are being done, to see that testers can work efficiently, to see that the tests are also written as, for example, new features are being developed. So in the case of the SUSE Linux distribution, of course, we always have new packages coming in and changes being made, and ideally we want to automate everything. But of course, this is always an uphill battle. So this is important to keep an eye on.
Yes, totally understand. So my last question is this. You have experience with a lot of things in test automation already. What is one feature you really like about openQA?
So I probably have to say more than one, but probably one thing I really like about it is the fact that you get a lot of tools on your hands to investigate what happens to your test cases. So you can, like I was showing earlier, you can have an overview of the latest tests that are running. You can have an overview based on a certain group that you want to investigate. If you're looking at a specific type of software, and you get both the sort of user-based view of things. You can see what the state of the test is in, what happened on the screen, if a test is failing, for example, or if it's succeeding. But you can always also look at the full logs of everything. So you can see what the serial console does. You can see if something is happening in the system logs. You can see if the test run itself was producing any logs. You always have various types of information to investigate what's actually going on.
Okay, perfect. Thank you that you joined us and presented openQA. And I hope that sometime we also see each other in person. Thank you very much.
I hope so. Thank you for having me.